This is the exam 2 review. So it starts off with linear and logistic growth. And so I'm just going to go through these questions and then ask questions if you have them. So the first one says the number of streetlights in a town is growing linearly. 4 months ago, which is our N naught, our N equals 0, our P naught, there were 26 lights. Now, P sub 4, there's 50 lights. And you have to know what the formula is. So it's P sub N equals P naught. P naught plus D times N. So we know, let me do it in this order. So the initial is 26. We don't know the rate, but we know after 4 years, the population or the amount of streetlights is 50. So then we subtract 26. We get 24 equals D times 4. We divide by 4. D equals 6. So then we plug that back into our formula and we get 26 plus 6N. And that would be the explicit formula. And then how many months will it take to reach 209 lights? We just set that equal to 209 and we're solving for N. This says 30.5. It says round up to the nearest month. So we would put 31. Okay, the next one, you know a population grows according to this recursive rule with the initial population of P naught equals 60. The rule says that you're adding 35. So it's 60 plus 35, which is 95. And then the next year, P sub 2 is 95 plus 35, which is 130. And then the next part is that you need to write an explicit equation. So we know that the initial is 60, and we know that it's going up by 35 each year. And then we're going to use that explicit formula to find the population after 10 years. N is the number of years. So you would just do 60 plus 35 times 10. And you get 410. So that's it for the linear questions. You should know how to write an equation. You should know how to solve for the rate, and you should know what to do once you, if you're given this, you should know how to solve for N, and then you should know what to do if it gives you N to find P sub N. That's all of the types of questions that you'll see for linear functions. The next one is with a carrying capacity. So there's fish in a pond and it has a carrying capacity. And so you're using the logistic equation where P naught is 300, K, which is the carrying capacity, is 1100. And R is 2.5 when we write it as a percent. And you'll have your formula sheet. The formula on the formula sheet is P sub n equals P sub n minus 1 plus R times 1 minus P sub n minus 1 over K times P sub n minus 1. So now plugging this in, if we're trying to find, I'm going to write this up here. If we're trying to find P sub 1, then P sub n minus 1, how should I write this? So we have P sub n equals P sub n minus 1 plus R times all of that stuff. So if you're trying to find P sub 1, this is P sub 1 minus 1, which is P naught. So that's why you use the previous population. This means the previous year's population, because like you see right here, 1 minus 1 is 0. If this was 2, then it would be 2 minus 1, and you'd be using P sub 1 as the previous population. So for P sub 1, it's 300 plus 2.5 times 1 minus 300 over 1100 times 300. And I'm just going to type that into my calculator really quick. And that gives you 845.45. And according to this, it just says round estimate to the nearest fish. So this is less than 5, right? So we don't round up. We would just say 845. If it said round up to the nearest fish, then that means whatever it is, you just round it up. But this just says round to the nearest fish. So we would put 845. And then we're going to plug in all of that again. So P sub 2, the second population, now we're using P sub 1 on here. And I'm going to type that into my calculator. And you get 1334.7. So because this is 0.7, you would round, that would round up to 1,335. And this was, we had 3 types of growth models. So we had linear, exponential, and logistic. This was one of the growth models. There will be one of these questions on your exam, for sure. Okay, the next section is exponential growth. So exponential growth, the formula is written in the first problem, but it won't be written in the problem for you on the test. You'll just use the formula sheet. So it's P sub n equals P naught times 1 plus R to the n, where R is the rate, n is the year or the time period, and then P naught is the initial. So Provo's population in 2020 was about 117,000 and has been growing according to this exponential growth model at about 9%. If this continues, what will Provo's population be in 2029? So 2020 to 2029 means that n is 9 It's 9 years later. And so now we have everything we need. We're trying to find P sub 9. And it's 117,000 times 1 plus 0.09 to the 9th power, because it's 9% and 9 years. When you type that in your calculator, I got 254,111.5. And on this one, it says round population to the nearest 1,000 people. So this would be 254,000 people. If this number was 5 or above, then you'd round it up, but it's not. So it would be 254,000 people. Next is about home prices. So the initial cost of the home is $154,000. The rate is 4.7, so we would write 0.047. And then it says in what year, so we don't know what N is. In what year would the home be worth $269,000? And how we solve these problems is you divide by the number in front, which is 154,000. And I'm going to come up here. So then we have 269,000 over 154,000 equals 1.047 to the n. And when we have an unknown exponent, this is the base of the exponent, so we have to use a log. So we do log base 1.047 of our fraction. And then if we do that on both sides, then the n can come down in front, and then the log base 1.047 of 1.047, they just cancel out. They simplify to 1. So then we can just do the change of base formula. So we do log of the big number. That should be in parentheses, over log of the base. And that's because the scientific calculators can't do scientific calculators can't change the base. So we have to change the base, use the change of base formula so that you can get the answer. Okay, and I got 12.1. That's how many years. And then it says, in what year would it be this? Would it be this cost? So you purchased the home in 2014. 12 years later would be 2026. So one thing with this is that first number is not the right number for what you're using. It says that you purchased the home in 2014. So the first year that they give you is extra information that you don't need to use. Okay. The next one, suppose a fish population is currently 3,500 and 7 years later, the population is 10,000. And this is growing exponentially. So the initial population is 35,000. We don't know the rate. That's what we're trying to find. But 7 years later, the population is 10,000. And then we're solving for R. So we need to divide. Again, just like the previous problem, we're going to divide by the initial population. And we get 10,000 over 3,500 equals 1 plus R to the 7th power. This time we don't know the base of the exponent, but we do know that the exponent is 7. So the way we undo an exponent is by doing the root. So we're going to do the 7th root on both sides. We get 1 plus r equals the 7th root of 10,000 over 3,500. So now I just need to do that. And this is 1.162 when we round it. And it says that we want the rate as a percentage to the nearest tenth. So if 1 plus r is 1.162, when we subtract 1, r is 0.162, and as a percent, that would be 16.2%. Okay, the next one, we have a population of a small town that's growing and it gives us the rate. How many years? So this is the same as the first one we did. We're trying to find, so the population is 15,000, and then it's 1 plus 0.012 to the n. We're trying to find when it reaches 27,000. So we divide by 15,000. And I'm going to simplify this to 27 over 15 because it's 27,000 over 15,000. So the fraction, it doesn't matter if we simplify it a little bit right there. And then we're going to do the log. So we do log base 1.012 of 27 over 15 equals n, because when we do log base 1.012 of 1.012, those just simplify to 1. And then we do the change of base formula. So this would be log of 27 over 15. Let me rewrite that so it's a little bit more clear. 15 over log of 1.012. Now I just need to type that in my calculator. Okay, and I got n equals 49.28. So if it's asking us to round down to the nearest year, it would just be 49. It doesn't tell us what year the first population is. So this population, it told us it was 2014 right here. So then we would do 2014 plus 12, and that gives us the year because it says in what year, but then this just says how many years. So that's why we put 49 on this problem. Okay, and then the last problem is going to be the same. We're trying to find the rate. So it's going to be the same as this one right here, where we're trying to find R. So a native wolf species has been reintroduced into a national forest. Originally, 200 wolves were transplanted, so that's our original. And then after 3 years, the number of wolves grew to 778. And so we do the same process. We're going to divide by the initial population. We have 778 over 200 equals 1 plus r to the third power. And we do the cube root, or the third root. So 1 plus r, if I type that in my calculator, is 573 when we round. Let's see. It says write growth rate as a percent to 3 decimal places. So I think I actually need to write out more of these decimals. So I'm going to do 1.57271. Then we subtract 1 from each side. So R is 0.57271 or 57.271%. So that's what we'd put up here. And then if this trend continues, how many wolves will there be in 10 years? So instead of having it be 3 years, we'll replace that with 10. So we would have P sub 10 equals 200 times 1.57271 to the 10th. And that one you just need to plug it into your calculator. And I got 18,514.7. And it says round down specifically. So round down, even though this is 0.7, it wants 18,514 wolves as the answer. Okay, and then our last part to this one is how long will it take for the population to grow to 1,000 wolves? So 1,000 equals 200 times 1.57271 to the nth power. So this is basically everything that you would need to know about exponential problems, because you have to find R and now you have to find N. You have to plug it in. So this is everything that you could be asked about for an exponential problem. And then 1,000 divided by 200 is 5. So I just wrote 5. 1.57271 to the n. We do log on both sides. So you would do log base 1.57271 of 5 equals n. The change of base formula tells us that it's log of 5 over log of 1.57271. And I'm using that many decimals because that's what it wanted for the first part. So I'm just going to use that number throughout because that's probably what it wants you to do. If it's asking you to write out that many decimals for one answer, that's probably what you should do for all of them. So I got 3.55. And it says round to the nearest tenth of a year. So this makes it round up to 3.6 years. And that's it for growth models. So with the growth models, you could see linear, exponential, or logistic, and you won't see a problem that doesn't match with one of these. There won't be like a method or a type of problem that isn't on the review on the exam. Then we did finance. So the first section is compound interest and annuities. The annuities I had to split up between two different columns on the Jeopardy game. So that's why there's like compound interest and annuities, and then annuities and payout annuities. And then the last section is loans. So again, this one you have to practice just looking at a problem and seeing, is this a compound interest problem? Is it an annuity, or is it a payout annuity, or is it a loan? So on number 1, or I guess the 100-point question, it says you deposit $200 in an account. It doesn't say anything about depositing money more than once or regularly. And don't get confused that it says compounded annually, because on any compound interest question, it has to tell you the compounding frequency, but it won't say that you deposited money more than once. It just says you deposit $200 in an account. So that's the compound interest formula. That's P sub n equals P naught times 1 plus R over N to the N times T, where N is the compounding frequency and T is the time, R is the rate. So how much money do you have in the account after 20 years? That would be 200 times 1 plus 0.03 over 1, because the compounding frequency is, let me write this down, N is the compounding frequency which is how many compounds in a year. So if it's only compounding once, if it's only compounding annually, that's only once per year. If it's monthly, that's 12 times per year. Weekly would be 52. Semi-annually is 2 times a year. I think those are the most common ones that you'll see. So anyway, we would put 1 as our denominator, and then in the exponent, we would do 20 times 1. And I'm going to type that in my calculator. And I get 361 and 22 cents. So that's how much would be in the account after 20 years. You deposit $200. At the end of the 20 years, you'd have $361. Okay, then the next one, you deposit $5,000 in an account. It doesn't say every month. It doesn't say every year. It doesn't say anything about depositing that money more than once. It does say that it's compounded monthly, so that means our compounding frequency is 12, but it doesn't say anything about depositing that money monthly. How much will you have in the account in 15 years? So you deposit $5,000 in an account earning 2% interest, compounded monthly, and we just plug all that into our calculator. You put it in the formula, and then you plug it into your calculator. So this would be $6,747.61. I'm just going to check something really quick. Okay, so that's it for compound interest. You just use the compound interest formula, you plug it in and find the answer. It's a lot simpler than annuities or payout annuities or loans. So the next one, you deposit $1,000 each year. So this each year part is what tells you it's an annuity. And that means that we have to use the one of the big formulas. And I'm just going to write it down over here. So this is an annuity. So you do P sub n equals P naught. Nope, not P naught, sorry. And I actually think that this uses A. The amount in the account is D times 1 plus R over N to the N times T minus 1 over R over N. So the deposit amount is $1,000. And then it's 1 plus the interest rate. It's compounded monthly times 15 years, and then we have our minus 1, and then you have your denominator. So I'm going to take a minute and plug all that into my calculator. And remember, I've been saying that one of the skills that you need to have for this section is being able to type things in the calculator correctly, because if you aren't practicing that, then how will you know on the exam if your answer is correct, or how can you be confident that you typed it in correctly? But if you have been practicing by doing the homework and you're finding like common mistakes that you're making or where you need to put parentheses and stuff like that, then you should feel more confident with taking the exam. Oh, you know what? I see my mistake. This says compounded annually. Oops. So all of these 12s should actually be 1s. Oops. So let's try that again. I was like, I did not get the right answer. Okay, so it's not 12, sorry. It's to the 15 times 1 minus 1 all over 0.06 times 1. So let me fix that really quick. Okay, so this answer is not the correct answer. So you would have $23,275.97. There we go. So obviously it's important to look at the compounding frequency and make sure that you're putting the right number. Okay, now we have another one. This says you're depositing $400 each month. So that means it's an annuity, 5% interest, compounded monthly. So that's 12. How much will you have in 30 years? So we use the same formula. We have 400 times 1 plus 0.05 over 12 to the 12 times 30 minus 1 over, all over 0.05 over 12. And I'm going to erase this 12 right here so that it's not confusing. Right there. Okay, and then you just type that in. So I'm going to type that in. Okay, and so for the first part, the amount in the account is $332,903.45. Part B is how much total money will you put into the account? You're putting in $400 12 times a year for 30 years. When you multiply that out, you get $144,000. So how much interest do you earn? If you have $332,903.45 in the account and you only put in $144,000 of it, then $188,903.45 would be the interest. Okay. Now, another type of problem that you'll see with an annuity is saying how much you want to have in the account. So if you want to have $500,000 in your account, how much do you need to deposit each month? So that's, you're solving for D. But it's still an annuity because you're saving up for retirement. And then this would be 20 times 12 And then that would be what we plug in. And then just like we've done in class, to get D by itself, you're going to divide by this on both sides. So you would have D equals 500,000 over 1 plus 0.09 over 12 to the 20 times 12 minus 1 over 0.09 over 12. Okay, and then when you type that all in, D should be 748.63. And then part B says how much interest will you earn? So that skips this part that you have to calculate, which is how much money did you put in? So then how much is interest? What you put in is 748.63 times 12, and it's 20 years. So let me just type that in my calculator. Okay, so what you put in is $179,671.20. And the amount in the account was 500,000. That's what you were saving for. And you subtract off what you put in, you get $320,328.80. I think I'm looking at the Jeopardy key, and it says 329, and that's rounding up, but you wouldn't round up in that situation. So this is what the answer should be. Okay, so you could be given information like this, where you're just finding out how much was in the account, how much you put in, how much is interest. You could be asked how to find the deposit amount. That's kind of it for annuities. How much is in the account, or how much do you have to put in the account each month? And as long as you are familiar with the formula, then you should be fine. This one says, suppose you want to have $600,000 in the account for retirement. How much do you need to deposit? So this is still an annuity. You're adding money into the account. And so I'm just going to set this up. This would be 600,000 equals D times 1 plus 0.09 over 12 to the 12 times 25 over minus 1 over 0.09 over 25, or over 12. Gosh, I wrote 12, but I said 25. Okay, so how much would you need to deposit in the account each month? You would do D equals 600,000 over this big fraction. And you should get 535.18. So $535.18. And then the next part is how much interest will you earn? So if you're putting in $535.18 every month for 25 years, then you would put in you would put in $160,554. So then to find the interest, I don't know where to write this. You know that there's 600,000 in the account minus what you put in, and you would have, let me just make sure this is right. $439 and $439,446 is how much interest you would earn. Suppose you waited 10 years, how much would you have to deposit to match that? So the deposit amount would be 600,000 over 1 plus 0.09 over 12. And instead of having it be in there for 25 years, now you only have 15 years. So if you waited 10 years, you don't get all of that interest and all of those compounds. So you would have to put in $1,585.60 in order to have the same amount, that same 600,000 by the end of by the time you retire. So it pays to start early is the point of that question. Okay, now we have payout annuities. So you've saved up for retirement, you have your retirement fund, and now you want to be able to withdraw money each month. So if it says withdrawals, or how much money will you pull out of the account, those are payout annuities. And that is the last formula on the formula sheet. So you've saved up 500,000. You want to know how much you can pull out each month. So we do D times 1 minus 1 plus. The interest rate is 8%. And this one has a negative exponent because you're taking money out. The amount in the account is going down. And then we do the same thing. We divide. So we would do 500,000 divided by this whole big fraction. And you should get D equals $3,859.08. And that's it for that question. That's how much you would be able to pull out from that retirement account each month. This one is a little bit different because it says you want to withdraw money each year. So the compounding frequency is going to be 1. It's not going to compound monthly. It's going to compound yearly, the same as the withdrawals. So how much do you need to have in the account at the beginning? You need to have, we don't know the amount in the account, but we know that you want to be able to pull out 35,000, and then we just plug in everything else with a compounding frequency of 1. And according to the key that I made, it should be $447,417.47. Lots of 4s and 7s on that answer. Okay, how much total money will you pull out of the account? You're pulling out $35,000 once a year for 25 years. So you're pulling out $875,000 over the course of the retirement account for 25 years. So then if you pull out $875,000 and you only had 447,417 and 47 cents to begin with, then the rest is interest. So that would be 427,582 and 53 cents. So again, those are the two types of questions that you could be asked. How much can you withdraw each month? Or if you withdraw this amount, what do you need to have to start? Those are the only two types of questions that you could be asked. They might look a little bit different, but essentially those are the only two things that you would be finding. It's never going to ask you for the interest rate. It's never going to ask you for the time or anything like that. You'll be finding the deposit or the withdrawal amount, or you'll be finding the amount in the account. So those are payout annuities. And then the last section is loans. So for loans, this is using the last formula as well. And some of these have a down payment. So you could put a down payment down on a house, or you could put a down payment down on a car, and that reduces the amount of the loan. So in the first one, it says, suppose you want to buy a car for $11,500. You put a down payment of $2,000. You decide to put a down payment of $2,000 and finance the rest. So the loan amount is $11,500. Oops, one extra zero, minus $2,000. So the loan amount is only $9,500. And then it says, what will your monthly payment be? So 9,500 equals D times 1 minus 1 plus 0.05125 over 12, because it's a monthly payment. And it's 5 years. Once a month for 5 years. So 5 times 12 is 60. So you can put negative 60 up here or negative 5 times 12. It doesn't matter which one you use, as long as you don't do negative 5 times 60, because that has happened and that is incorrect. Okay, so what would your monthly payment be if you do 9,500 divided by this big old fraction? Then you would get a monthly payment of $179.82. Next, you want to buy a $26,000 car. It's offering a 2% interest rate, which is crazy low right now, for 60 months. So this time there's no down payment. So you would just do 26,000 equals D times 1 minus 1 plus 0.02 over 12 to the negative 60 over 0.02 times 12, or over 12. So you do, let me erase that equal sign. When you do 26,000, you would do 26,000 over 1 minus 1 plus 0.02 over 12 to the negative 60 over 0.02 divided by 12. So that would be $455.72. Okay, so that's finding the monthly payment. You could also be asked how big of a loan you can afford. So in this problem, we don't know the amount, but we do know you can afford $300 a month. The interest rate is 3%. You're making a monthly payment, so the compounding frequency will be monthly. And then it's to the negative 3 times 12, because it says for 3 years. So on that one, all you have to do is type it into your calculator. You don't have to do you don't have to divide by the big fraction. You just type it in, and you can afford a $10,315.94 loan. if you can pay $300 a month at 3% interest. And you only have the loan for 3 years. Typically, it's 5 years, but you can go down as low as 3 or as long as 6, usually. Okay, and then we have 2 home loan questions, which is called a mortgage. So you want to buy a $226,000 home. You plan to pay 5% as a down payment and take out a 30-year loan for the rest. So the down payment is 226,000 times 5%, which is 11,300. So the loan amount is going to be $226,000 minus your down payment, because you've already paid that. You don't have to get a loan for that portion, which is $214,700. So then, is that it? That's all I wanted you to do on that question. Cool. Just the down payment. Just taking off the down payment. Easy. Okay. I left myself lots of space because I didn't realize that was just the short, like a short question. Okay. And then our last one is you can afford $1,500 per month mortgage payment. You found a 30-year loan at 8% interest. How big of a loan can you afford? So the amount is, okay, cool. 1,500 times 1 minus 1 plus 0.08 over 12 to the negative 30 times 12 over 0.08 over 12. So you can afford a $204,425.24. You can afford that for a loan. How much total money will you pay the loan company? Well, you're paying $1,500 a month for 30 years. So that's going to be $540,000 that you're paying. Let me write these in the blanks. And 540,000, like that. So how much money of that is interest? So you're paying 540,000, but you only took out a loan for 204,425 and 24 cents. So then everything else, the difference would be the interest that you're paying the bank to borrow that money for your loan. So it'd be $335,574.76 in interest, which is pretty typical. That's a high interest rate. 8% is a high interest rate. We definitely saw interest rates that high recently, but now they're more around 5%. So the lower the interest rate, the less interest you're going to pay on the loan overall over the course of the 30 years. So there's your review. Again, with loans, you might need to find the loan amount like this or the payment amount. Okay. And then how much did you pay? How much of that is interest? Those are the only type of questions that you'll see for loans. So overall, you should, if you feel comfortable, feel confident with all of those questions, then you should do great on your exam on Thursday.